Well, hey, Math 8, and welcome to the last day of school, at least as far as eighth grade math is concerned. So this is 520. This will be technically, this is on Wednesday, 520. Hopefully, you've already completed 511 and you've completed the graphing project. And this is hopefully your last assignment that you'll have to do. There's no survey because there's no more weeks to make a survey for to adjust anything for. So yeah, this is it. Last assignment, last day of school. All right, we're back to 3 attempts, kind of like what we've done typically on our Canvas assignment. So you will have 3 attempts, but once again, use them wisely. Obviously, if you need help, email me, reach out on Zoom. Take advantage of those extra 2 attempts you have. If you get one wrong, go back, figure out why you got it wrong, ask me, or make a guess at maybe what the answer would be the second time around. Get a higher score. So this will, of course, go into Skyward. All right. Beyond that, the notes and examples here. So graphs are a useful way to depict data because the reader can visualize the data and make comparisons. However, here's the bottom line here for this assignment. If graphs are not drawn correctly, a reader may make incorrect assumptions. So it's possible that we have a graph that is misleading. We have a graph that is inaccurate or even sometimes meant to kind of communicate something that maybe the data doesn't really actually say that much, right? You can kind of blow something out of proportion or kind of make the data say what you want it to say. And this is a good thing for you guys to realize as educated people and citizens in this country, is that sometimes when you see data, there's more than what it seems to say, right? If they show you a nice graphical display, sometimes you need to think, okay, how did they make that graph? Is that really the story, the full story? Or are they kind of just giving me a small slice that maybe just kind of says what they wanted to say? It's possible. I'm not saying that's always happening, but it is possible that sometimes graphs can be misleading. And so that's important for us to realize. All right, so here's some common errors or things to look for where graphs can be misleading. So first, the scale does not start at 0. Okay, so if the scale does not start at 0, for example, let's look at example 1. Chart A here, the U.S. poverty rate. Notice it starts at the percent of 11, not 0. Doesn't go 0 to 100. It goes 11, 12, 13, 14, 15, 16. From here, it looks like poverty is jumping leaps and bounds, right? I mean, I guess there's some bars that are close together, but look here. Like 1995, we're up here. That bar's pretty high. 2000, we go down to there. It's like, whoa, what happened? Between 95 and 2000. And the poverty rate honestly did go down. So I mean, they're not wrong. However, it looks like that it like went down like it was like 1/10 the poverty rate, or like it just went down leaps and bounds. But if you look at this, it really just went from a little under 14% to a little under 12%. So not a huge jump. I mean, a jump, sure, but not quite what the graph kind of communicates here. And then same thing, right? 2005 to 2010, like, whoa, what happened? Obviously, we had the economic recession of 2008. For those who may remember that or be aware of that. But once again, we went from 13% to about 15%. So not quite as big as these graphs seem to say. So that would be an example of a scale that does not start at 0. So if you notice, the data appears to be closer or further apart. If the scale does not start at 0, you cannot compare the height of bars or lines. You must use the scale. I had to look over here at actually what the percent was and rattle that off versus just saying, hey, look, between 2005 2010, the poverty rate more than doubled, right? Because the height of that bar more than doubles, but the poverty rate didn't more than double because once again, it didn't start at 0. All right, second, pictures or bars are not drawn proportionally. So this makes the reader think that there was a larger or smaller change than there actually was. And so if they're not drawn proportionally, it's kind of a similar type of issue as even what we saw here. If they're not drawn proportionally, then once again, you would think, hey, that bar more than doubles, but it didn't actually. So that's kind of a similar issue there. Third, when comparing two graphs that are using different scales, okay, so it's difficult to compare the data when the scales are not the same, and you would want to use a double bar or a line graph instead. The strengths of those is a double bar or a line graph. You have to use the same scales. So for example, here, you notice these two graphs are both the U.S. poverty rate. Okay, I don't know if you noticed that. Chart A, chart B, they're both actually saying the same thing. It's the U.S. poverty rate. They both start in 1970. They both go to 2010. But notice here, the percent over here is, as we said earlier, this one doesn't start at 0. It goes 11, 12, 13, 14, 15, 16. The percent here does start at 0, and it goes 0, 2, 4, 6, 8, all the way up to 20. Okay, so if I'm comparing these, once again, here it looks like 2005, there wasn't much poverty. 2010, there's a ton of poverty. But this is actually what was happening, right? It wasn't that more than doubled jump of the bar that looks like it happens here with the red bars. Over here, you can see a little bit more of what's going on. But do you see how it would be even kind of hard to compare these two? If you were trying to look at maybe two different countries, say like chart A was like Canada's poverty rate and chart B was the US's poverty rate, and one had that scale, man, you would look at the US and be like, man, there's like hardly any change in poverty. Canada over here is going all over the place. And maybe it isn't actually. Maybe it's just the chart that makes it look like. And because they have different scales, you're trying to compare apples and oranges, but if one has a different scale than the other, then you're not really going to be able to compare very well. All right, so that's problem number 3. Problem number 4, when making a histogram, unequal intervals. So your frequencies are not comparable because the intervals are different sizes, which changes how many pieces of data are actually in each category. Right? That's an interesting way to really kind of make it misleading. So here's example 2, where you've got a frequency chart. And if you notice here, the first one, right, 5 to 15, that's a size of 10. But then 15 to 20, that's a size of 5. Those aren't the same size, right? Either the classes or intervals have to be 10 or they have to be 5. One can't be 10 and one can't be 5. Next one, 5, 5, 5, 5. Yeah, all the rest are 5. That first one's 10. It's kind of convenient. So notice, looks like the number of students is about the same, 10, 12, 12 for those first 3. But look, the first one had an extra big class. So there's not really, like if you look at just 10 through 15, like a size of 5 like all the others, there's probably not actually 10 students there, probably a few less likely. So once again, the intervals are made with different sizes. They say here the frequency chart was created with intervals that are not all the same size. The first interval from 5 to 15, which is an 11-minute spread, where all the rest, of course, are a 5-minute spread, as we saw. Yeah, that's kind of an example of that fourth thing. Histogram not having the same size bars there, or same size intervals. All right, well, those are just some examples of some graphs here that are misleading. And once again, really those 4 main reasons are the main reasons typically why graphs are misleading. There are some others out there as well, but those are the main ones that we're going to cover here with today's notes. So as always, if you have questions, email me or hop on Zoom for help. Otherwise, I hope you guys have a great summer, and I wish you guys all the best next year at VHS. So hope you guys have a great summer.